Hi folks, Harry Frank from Red Giant here, and in this tutorial I'd like to talk about air physics. When I say air physics, I'm referring to the section in particular called physics, and then under physics we have a section called air. There's actually two physics models inside Trapcode particular, and we can only use one at a time. Up here we have a pop-up that allows us to define which physics model we're using, air or bounce physics, which I'll cover in a later tutorial. And if I twirl open air, we can see all the controls that we have for air physics. Now, between these two physics models, air and bounce, we have two parameters that are accessible to both physics models, gravity and the physics time factor. And I'll go into all of these and more in this tutorial. In a later tutorial, I'll talk all about the bounce physics model in Trapcode particular. But first, let's talk about air physics. Now first, let me calm any fears you might have about a section called the physics section. You don't really have to have an understanding of physics. Physics just refers to any physical properties or physical phenomena that might occur to matter and energy, but in this case we're talking about simulated particles. And we're going to simulate physical properties like gravity or wind or air turbulence. So there's really no complicated math involved, but there are a couple concepts to understand. And the first one I'd like to talk about is gravity. Now gravity might seem pretty straightforward. If I turn it up, particles will start to go downward. Now let me move this emitter up just a little bit. The important thing to understand about gravity is that it's not just a direction or a velocity that we're pushing particles in. And in fact, it's not velocity at all. Velocity is a constant motion. Gravity is an accelerating motion. Gravity makes things accelerate. So when we talk about gravity, the effect of gravity is to cause things to accelerate in the direction of gravity. So don't think of it as a velocity, like this particle is simply going to move downward. This particle is going to accelerate downward. So it's going to go faster and faster. Now this is good to understand because sometimes I see, let's say, rain simulations where the emitter is put just above where the comp view is. And if I say, make this a box emitter, and I pull my X out here, and let's say I'm trying to make rain or snow. Let me turn up the gravity. What I can tell is that the particles are kind of being born right up here, and they start fairly slow, and then they start to speed up. So I can kind of tell that their velocity due to the acceleration is fairly low right here and fairly high down here. And this makes for a fairly unrealistic simulation. It looks like somebody's basically shaking a box of snowflakes right above the camera. So when we want things like realistic rain or snow, don't think of gravity as just a way to pull things downward. Think about it in a smart way. Maybe we want a mix of gravity, but also the right type of emitter that will shoot things in a specific direction with a velocity that matches the type of simulation that we're going for. And maybe I even want to push the emitter much further up so I get enough time to have particles accelerate before they become visible. It's just something good to know about gravity. Now the physics time factor acts as a global time throttle for everything that has happened up until this point. So a setting of 1 means a 1-to-1 ratio of time inside particular and time inside my composition. So a 1-to-1 ratio means that time moves at its normal speed. However, if I turn this up, let's say to 4, the time ratio is now going to be 4-to-1. So particular is going to move 4 times as fast as our composition time. So for every 1 second that passes in our composition, 4 seconds will pass in particular. So if I reset this, we can do something cool like set this to a very high physics time factor and create a bit of an explosion, but then have this go much slower immediately afterward. So gravity and physics time factor are common to both physics models, and as we move forward you'll see why. Now the example I'm going to show you, which is sort of this pixie dust, isn't going to use some of the properties in the physics section, but I do want to get through everything in here. So let me briefly talk about the things that are not part of my example, which are the motion path and then the spherical field I'll cover in a little bit. But motion path is first, so it's good to cover what the motion path is. So to use motion path, I have to create a light, and I need to name this motion path. And I also need a number there because I can use multiple motion paths. But understand this, I can only use one motion path per layer of particular. So when I say my light is motion path 1, and I'm going to use a point light, what I'm going to do is just do a basic animation. So let's just set a couple keyframes here so this moves from one side of the screen to the other and has a little bit of a curve to it. Now if I set my emitter to lights, I need to change this to emitter real quickly. We can emit particles using this light, and this light is moving on this path. But when I create particles, they have a velocity and they're immediately going to move away from this emitter. The purpose of the motion path is to emit particles along this path, and they will travel along this path continuously. So first thing to understand is that motion paths and light emitters are not the same thing. My emitter type does not have to be lights. In fact, it really should not be lights. It should be something else like point or box. I'll set it to point right now because motion paths and light emitters are not the same thing. I'm going to keep saying that over and over because it's a little bit confusing. So I do want a different type of emitter, and I will go to motion path and set this to motion path 1. Now what we need to do are align the two worlds that we're working with. You can see that it's kind of taken along that same path. And they also have their velocity at 100. I'm going to turn this down, let's say, to 20. So it's kind of moving along that path, but it's in a different spot. What we need to do is align our particular position, which is right here, with the position of our light. And specifically, we need to align it at the very first frame. And I have a tutorial on how to automate this with expressions, but I will simply do this manually for this example. So I'm going to go to my position here where my motion path is, and I'm going to type in these values. So 225.8, 199.2, and negative 329.9. There. Now if I play this, I've aligned my two worlds and everything is happening the way I expect. Let's go to the particle section and turn up the lifespan so that it has a little bit more life there. So that's the motion path. It works a little bit differently than using light emitters. It allows us to emit particles that move along a path continuously. Moving on, we have air resistance. Now, as you might guess, as the particles move through space, we can introduce some resistance to them. And much like gravity, where gravity has a particle accelerate in the direction of the gravity, as particles are moving in whichever direction they are moving. Let's actually turn up the velocity here so that we have particles straying from that motion path. As the particles move through space with their own velocity, air resistance will cause a deceleration, sort of a resistance to their motion. Higher the air resistance, the slower the particles will go, or actually the more they will decelerate. And if I'm using a particle that actually has some sort of rotation to it, which is possible either with a custom particle or simply using the star, and if I have a rotation speed on here and they're moving fairly quickly, I can also have the air resistance resist that rotation as they are rotating. It's not something I use that often, but it's good to have. Let's set this back to a sphere and move on to spin amplitude. Spin amplitude, spin frequency, and fade in spin all go together. In fact, they could almost be in their own little section, but well, we've got enough sections here, so they're all just kind of sitting there on their own. But they do work together. So what these three things do are introduce a up and down motion of the particle along its path. Now what I'm going to do just to see this path is actually turn on the aux system down here. So let's go to aux system, and I'm going to emit particles continuously, which means I'm turning these main particles, these white particles, these are all becoming emitters themselves. The particles that are result from the aux system is called the aux particles, and that's the little rainbow colored ones that you see in there. I'm going to turn the size down to 2, but I'll turn the particles per second up to about 100. So essentially what we're seeing is a trail behind each of the main particles. So the main particles are the white particles, the aux system is the spectrum colored particles. So, and I do this so we can see the results of the spin parameters that I'm going to show you here. So like I said, it's an up and down motion along its path, and it's specifically a sinusoidal motion, or basically just kind of a spring-like up and down motion. So how high they move along that up and down path is the amplitude. Now we have a fairly low frequency, so they're kind of doing these long sweeping motions. But if I turn this frequency up, we will see that we have more and more of these almost like scribbles. But if you look at any one particle, even though they're all moving in different rotations, they're basically moving up and down in sort of a cycling motion. The fade and spin is the time it takes for the spin to take effect on the particle after it's born. So right now it's 1 second. So a particle will be born, and it will travel for 1 full second, and then the spin will actually take effect. In fact, if we look down here, you can see this path right here, and right here at this sort of elbow is where the spin starts to take place on this one particular particle. Now I'm going to skip over turbulence field right now and cover something that's a little easier to describe. A spherical field is simply a spherical area in which we can define particles to either avoid or be pulled into. So if I set the strength to 100, and I'm going to turn on visualize fields so I can actually see where that sphere is. So I can see right here it's red. I'm going to turn up the radius and change its position to somewhere center of the screen. It's not interacting with the particles just yet because we have this Z position right here, and I need to move it into where my particles are. There we go. Actually, let's turn the radius down quite a bit. So the spherical field is simply a field where the particles will continue their path, but they will avoid that area if the strength is positive. If the strength is negative, they will move through that path and be sort of pulled towards the center of the field. So it's pretty straightforward. So backtracking up 1 to this turbulence field. I kind of left this one for last because it's possibly the most in-depth section we're going to talk about. And in fact, it's difficult to cover turbulence in any sort of detail without taking a great amount of time. So one thing I will say is that now I've covered this topic in a much greater detail in a different tutorial where I talk all about fractal fields, active multipliers, and active scales, and complexity in fractal scale, and all that kind of stuff. And we'll post the link for you in this tutorial. So I'd like to sort of give you the abridged version of what the turbulence field is. So let's do a little bit of background information here. When I talk about fractal noise, you can think of fractal noise exactly like the actual effect, fractal noise, which is located under effect, noise and grain, fractal noise. There are lots of different controls in here that you will find that are common between a standard fractal noise effect like evolution, scale, complexity, which is right here, contrast and brightness, that kind of thing. You will find a lot of commonalities between how this fractal noise works and how the fractal field in Trapcode particular works. In fact, let me turn off this layer here and start all the way at the bottom. Fractal noise is made of several layers of noise all laid on top of each other. Now, as fractals do, they lay on top of each other and take the same pattern but scale it down. So in this case, I've got one layer of noise at 6,400%, pretty big. The next one is scaled down by half, 3,200. This one is 1,600. Next one would be 800, 400, 200, and 100. So this is 7 layers of noise. This would be a fractal noise with a complexity of 7. How the scaling works between one layer to the next is one property, which is called the octave scale. And how the opacities relate from one layer to the next is called the octave multiplier. And these you will find in Trapcode particular, turbulence field, octave multiplier, and octave scale. The scale is the overall scale of the fractal, just like I showed you with that effect. There is an evolution speed, which has the fractal noise evolve over time, and a manual offset as well. Now, this doesn't do anything. So what does this do? Like I'm talking about this fractal field and fractal noise and turbulence field and all that. Well, what does this actually do? So if we take a look at fractal noise here, which I have manually constructed with my 7 layers of noise here. So what we have are areas of dark, we have areas of light, and we have areas in between. An area that is gray has no effect on particles. An area that is white has a maximum effect in one direction. An area that is black has a maximum effect in another direction. What we are affecting are 2 different things. We can affect the size of the particles, and right now I'm only affecting the main particles. So actually, why don't we, let's actually reset here. So this will be a good way to sort of start clean and reset my particles. So let's go to emitter. I'm going to set this to a box and really crank up our particles and give a fairly large area to work with. So under physics, air, turbulence, I said we can affect size or position. So if I turn this up, we can see sort of a fractal pattern turning the size up and the size down. And some of them will be in between that are unaffected. I can also affect the position. So again, positive white values push in one direction, negative black values push them the other direction, and gray values leave them alone. Just like we had with spin, we have a fade-in time. So there is a time after which particles are born where the turbulence field takes effect. Now, remember when I showed you the spin where that one particle had the little sort of joint where the spin took control of it. Turbulence, however, actually has a way to smooth that out. So we can have either a linear fade or a smooth fade to fade in the fractal field. All this other stuff right here from scale, complexity, octave multiplier, octave scale, evolution speed, and offset all relate directly to the fractal noise and the fractal properties of that fractal field. X, Y, and Z offsets are pretty straightforward. I can offset this fractal field, which obviously exists in 3 dimensions because particular is a 3-dimensional particle system. These basically just offset it in all 3 directions. And move with wind allows that fractal field to be pushed around with the wind that is inside the air section up here. So I know there's a lot of controls here. Let's just close that up. Hey, that's not too bad. It's just the physics section. Let's close everything else up. Physics model. We only have air and bounce, and we can only use one at a time. So this whole section down here isn't even going to do anything right now. So air simply has the motion path, which I showed you, air resistance. These 3 things are spin amplitude, which make the particle move up and down along its path. Wind, X, Y, and Z, not too bad. And then turbulence field. And actually, I didn't speak of the visualized fields. If I click this on, this will give us an X, Y, and Z spline that shows the deformations of the fractal field. So if I, let's say, turn up the complexity, or actually probably the scale would be a better way to show this. So if I turn this up, the fractal field actually becomes more compressed, and we'll see a lot more detail in the deformations of the fractal noise. I generally leave visualized fields off unless I'm working with a spherical field. And turbulence field, well, I just showed you in spherical field, actually isn't that complicated. Now I think the air physics section is probably the most complicated, and of that the turbulence field is probably the most complicated part of particular overall. But there's nothing terribly complex about what's going on. Most of the complexities have already been thought out for you and are presented in a pretty easy to control way. And quite honestly, you could probably go quite a while working with particular and making some amazing looking things without even touching things like scale, complexity, octave multiplier, and octave scale. So let's get back to this example that I was showing you to sort of show the power of particular and what is actually going on here. What are the different components that we're using? So let me reset this, and I'm going to actually copy the emitter that I have over here. Let's copy and paste that. All this is a point light, and it's moving around. So it's just got some keyframes that I can work with. Actually, let's trim this up to 20 seconds. So let's right click up here, trim to comp work area, and go to particular emitter, set this to a light emitter. Now what I want this to do is to emit mainly when the light is moving. And I want to show you a little trick here. I'm going to go to the particles per second and make a little expression. So I'm going to hold down Alt or Option, depending on our platform, and click on the stopwatch where it says particles per second. And what I've done is created an expression for my particles per second. So I'm going to automate the particles per second rather than manually animate it. And what I'm going to do is look at the position of the emitter by hitting P, and I'm going to grab the pick whip and pick whip the position. Now, After Effects is going to try to help me out here and do something automatically. Because position is what we call an array value, it has 3 different values that make up the one parameter. So x, y, and z are 3 different values. Particles per second is a scalar value. It only has 1 value. So After Effects kind of said, oh, you're making a mistake. You've tried to pull 3 values into 1. You can only match a scalar value to one part of an array. And what it's done is used position 0 in the array, which is the first value. So 0 would be this one, 1 and 2. 0, 1, and 2. But in this case, I'm not going to use its position specifically, but I'm going to use a property of the position, which is its speed, how fast it's moving. Now, backing up and talking a little bit about physics stuff, speed and velocity are 2 different things. Don't use the words interchangeably. Velocity has direction, negative or positive. Notice particular has velocity, that's negative or positive. But when I reference speed, speed is always positive. It's basically how fast it's moving and not taking into consideration any direction. So if it's moving fast this way or that way, speed isn't going to matter. It's just going to give us a readout of the speed. So when I plug the speed into the particles per second, that basically is going to give us a positive particle count every time the particles are moving. And then once it comes to a stop, it's going to come to 0. Actually near 0, because I do have a little bit of a wiggle expression on here. I'll just actually get rid of that so we can actually have a true 0 once it comes to a stop. So as it goes from this keyframe to this keyframe, and then it comes to stop, we have 0, and then we have particles, and then we have back to 0. If I'd like more or less, I could go in here and add perhaps a multiplier, like using an asterisk for multiplication, and then multiply that times 5. Now, in a case like this where I'd like some pixie dust, I probably want quite a bit of quite a few particles. Now, what's going to make this feel quite magical is jumping into that physics section and adding a little bit of real-world wind, turbulence, and gravity. So I'm going to add just a little bit of gravity to pull this dust down, maybe 35. I'm going to add a little bit of wind so that they drift ever so slightly to the right. And I'm going to go to the turbulence field and affect the position, let's say about 250. Now I'm going to go to the particle section and have the size over life start large and scale down. Let's actually set the lifespan maybe to 1.5. So if I play through this, Doesn't look too bad. I might have my turbulence field set a little bit high, but that's pretty okay. And let's turn up the gravity just a little bit more. Now, some of the motion that I've got here, as you can see, as it moves upward and then as it comes to stop, these particles all kind of get pulled to the right. Now, I do have that wind pushing it to the right just a little bit, but in addition to that, I have in my emitter section, by default, velocity from motion, which is set to 20%. So as these move, that motion, the velocity, which has direction, so it's moving in this direction, a positive direction, is going to inherit 20% of that. I'm going to turn this down, maybe about 8%, so it's not inheriting so much of that velocity. Maybe my gravity is a little bit strong. Let's go to gravity. Yeah, let's turn that down. It's dust. It shouldn't be pulled down that quickly. There we go. So when we have sort of a very fine dust like this, I often want to have a very high particle count and turn the particle size way down. Now, in screen captures like this, particle sizes at 1 or below often get lost. I'm going to sort of try to keep this as low as possible, but still visible to you. I'm going to go into my expression here and actually crank this up quite a bit. Let's say this is times 30, and we have quite a few particles in there. I'm going to go to color, make this a little bit blue, set the transfer mode or blending mode to add, so where the particles overlap we get a little bit of the colors adding together. And I'll turn the opacity down just a little bit. So this would be sort of like the fine dust part of it. Now I'll just take this and duplicate it and have particles that are quite large, let's say 4, but with quite a bit of size randomness. And I'll take this particles per second multiplier and get rid of that. In fact, maybe even divide it using a / and say 2. And I'm going to turn the velocity up so that these larger ones kind of drift away. And actually, I'm going to use a slightly brighter color for these. Like maybe the size could come up even more. And oh yeah, I turned the opacity down, so let me turn that up. Let's adjust the size just a little bit. And for these large ones, I would probably take this lifespan down maybe 1 second or a little bit less than a second. Now often when I'm making trails like this, and actually I should start labeling my layers. So I've got my dust, and these are sort of like the, I'll call these like glow bugs. Let's duplicate this one more time. And I'm going to have a high particle count, but a very, very short lifespan. And I'll take the size up, and size over life is pretty good. I'm also going to have the opacity over life fade out. And maybe change this color. I don't know. We'll try something purple. And we'll take the opacity down. So just something that floats along the head of the particles there. In fact, maybe I'll turn the velocity up just a little bit. And if I want, I can even expand the size around the emitter so that these are emitting in a larger area around that light. So that's an overview of the physics section. I know it's a lot to digest, and I feel like I've just sort of scratched the surface, but I wanted to do a walkthrough of the physics section in general. So now that we've got air complete, we'll move on to the bounce section in the next tutorial in this series. So I'll see you then. My name's Harry Frank. Thanks so much for watching.